Okay, you guys, we're going to answer questions on the assignment now. Okay. 34 and 42. Okay, we'll come to that one. Okay, problem number 34 asks us to solve each proportion. In 34, you're given x plus 2 over 16. I thought I did this one with you guys the other day. Equals 7 over 4. Okay. I think I did it right at the end of class to help some of you guys out. How do I solve this? Yeah, you cross multiply. I'm going to go 4 times x plus 2. So I multiplied this by this, right? And then I've got to go 16 times 7. I'm pretty sure I did this the other day. What's 16 times 7? 16 times 7. Someone get your calculator. Huh? 112, is it? Okay. And then I got to solve for x. What would I do to solve for x?
You gotta take 4.
How do I get rid of this 4?
No, you gotta times it into.
Well, I could, but the faster way to do it would just to divide by 4 right now. 4 divided by 4 cancels that out, and I get x plus 2. What's 112 divided by 4? 23? Or 28? And then minus 2 from both sides. And I get x equals 26. Okay? What was the other problem you wanted to know about? 42? If you're just saying that, don't ask. Do you need to know how to do it? Okay, 30. Okay, 3x over 27 equals 2/9. Okay, what would I do? Kate, you asked about this one. What would I do? Okay, what would I times by each other? Well, 3x and 9. What's 3x times 9? What's 3 times 9? So it's 27x. What else would I multiply? What do you get when you do that? Close. 54. Okay. What would I do to solve for x right here? Divide by 27. So x equals what? Okay. I'll do one more at the most. 32. 1 over x plus 3 equals what? Tell me, you guys. Huh? 3 over 29? Okay. What would you do on this one, you guys? Kate, what would you do on this one? One of these days you guys owe me. You'll have to replenish the box. All right. Okay. Right here, I would, you know what? Well, I would have divided 3 by both sides first. So you get 29 thirds equals, those cancel out and you get x plus 3, right? And what's the last thing you do? 3 is being added to x. What's the opposite of that? Minus. So you would get 29 thirds, which is 9 and 2 thirds. Subtract 3 equals x. What's 9 and 2 thirds? Subtract 3, you guys? 6 and 2 thirds should be the answer. Okay? All right, we're going to correct the assignment now. Hold on. Our objective today is to learn how to identify similar polygons. And there is the definition of a polygon. A closed figure in a plane formed by segments called sides. We have actually talked about polygons before. But these are examples of polygons. Yeah, that was a bad star, I admit it.
That doesn't help you any.
That doesn't make it
By the way, one of these polygons right here, we don't usually study in geometry. Which one is it? The star. Why? If it was a good star, would we study it? You guys, Matt? This is, right here, is a convex polygon, the star is. I mean, concave polygon. Remember when we talked about convex polygons and concave and convex polygons at the first of the year? Concave is where some of the vertices point in. That kind we don't generally study in high school geometry classes. If you took math classes beyond this, you probably will. But we study the other kinds. Quadrilaterals, pentagons, hexagons, triangles, and so forth, okay? So those are polygons. Now, what are similar polygons? Same shape, but not necessarily the same size. Think of a model airplane. Usually a model airplane is a scale replica of a larger airplane, right? A scale down, we say it's similar because the angles are all the same on it, but the lengths of the sides are not. But they're proportionally the same, which means, like, if you have on a real airplane, each foot of length on a real airplane might be represented by a quarter of an inch on a replica or a model. Yeah. How many of you guys have put together models before? When I was a kid, you always put together models, but there wasn't video games back then. So we did a lot more of that kind of stuff than most kids do now. But I'm impressed, like 5 of you raised your hand. That's pretty impressive. So, but models are just scaled down replicas of the larger thing. Okay? And so they're the same shape, but not the same size. Does that make sense when I say that? And the sides are proportionally the same. Okay, let's take these two triangles right here. Let's say that they're similar. This is a similarity statement right here. Okay, this little squiggly mark means similar. That's the symbol. See, the new symbol today. You guys just learned one. Triangle ABC is similar to triangle DEF. You already knew that symbol? That's cool. If you did. Okay. Okay. Hey, this is off, you guys. We're not talking about lasagna, which is one of my favorite foods. So, I know. All right. Okay, has everybody got this one down? Okay, definition of similar polygons. Two polygons are similar if and only if their corresponding parts are only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. I'll show you what that means in just a second. Write down the definition. Definition of similar polygons. Okay, so angles are congruent, but sides are proportional. If you think of two equilateral triangles, you can have, on an equilateral triangle, what is every angle? Yeah, same amount. They're 60 degrees, right? If you made a larger one, you'd have all three angles are 60 degrees. Now, those triangles are the same shape, but they're not the same size. One's larger than the other. Okay, on this picture right here, we're saying that angle B is congruent to angle E, angle A is congruent to angle D, and angle C is congruent to angle F. I think that's an F. That is an F. Okay? And therefore, and we're also saying that side AB, that's what we're saying right here, over side DE, side DE, they're in the same spots, aren't they? AB and DE is equal to the length of AC over DF is equal to the length BC over EF. Those ratios are all going to be the same. So if there was a 2-to-1 ratio on all of these, okay, let's say that there was a 2-to-1 ratio. Let's say that this length of side right here was 4. That would mean this one is 2. And if this one right here was, let's say it was 6, what would this one over here be?
7,000.
3. And if this one right here was 8, what would this one over here be? 4. And that's what we mean by proportional sides, okay? That there's a 1-to-2 ratio between them, okay? Because each one of those, or a 2-to-1, depending on which way you're going. If I went from here to here, it'd be 2 over 4, which is 1/2. But if I went from 4 to 2, that would be a 2-to-1 ratio, right? It doesn't matter which way you go, as long as you're consistent all the way across. All right? Any questions there? Okay. Now, why? Similarity is actually something that happens all the time, everywhere around us. Okay? But I can show you some examples here in just a second. Okay. Let's say you have these two triangles, and we want to identify, because this is our objective today. Learn to identify similar polygons. We want to know if these two are similar. Okay? Or we want to make X and Y numbers that would make these similar triangles. What is the ratio between these, you guys? Okay, 7 over 4 or 4 over 7. I usually like to write the smaller number on top. Okay, so 4 over 7 is the ratio. How did you get that, Matt?
That's 4 over 7.
Okay, because we're assuming that RT and JL are the sides that are going to be proportional, right? Okay, so if that's the case, 4 is to 7 as 5 is to X. Now, could we solve that and figure out what X is going to be? Okay, how would I go about solving this? Cross multiply, so I'm going to go 4 times X is 4X. 5 times 7 is 35. And I'm going to do what? Divide by 4. And I'm going to get X equals 35 fourths. What is 35 divided by 4? Put it in your calculator. 8.75. So X is 8.75, right? Okay, we can do the same thing and find L. What would we do to find L? I hit the wrong button. Okay, right here. What proportion am I going to write now? Okay, 6 over y plus 2. equals what?
That is
8.75 over 5. We can 5 over 8.75. That's right. Or why don't we use the one we know? What's the one we knew originally? 407. It's a little bit easier number to work with. Okay. Cross multiply again. What's 6 times 7? 42. What's 4 times y plus 2? Yeah. Like we were doing before, you guys, we could distribute that 4, or we could just divide right now by 4, couldn't we? If I divide by 4, those cancel out, and I get y plus 2 equals, how many times is 44 going to 42? You guys know this one in your head. 10.5. Well, it goes into 10, 4 will go into 40 10 times, right? You have 2 left over. 2 over 4 is a half. Okay, and then minus 2 from both sides, right? And I get y equals 8.5 as well, right? Wait, that can't be right. Because we got 8.5 on the other one. Oh, we got 8.75, so that's right. Okay? Sticks is a little bit bigger than 5, so wait, that number should be bigger. We did something wrong. Which one did we solve wrong? 35. 4 will go into that 8.75 times, that's right. Right down here, we had 6 over y plus 2 equals 4 over 7. Yeah, we did that. So we went 6 times 7. What's 6 times 7, you guys? Yeah. And 4 times y plus 2 is 4 times y plus 2. I divide both sides by 4. I get y plus 2 equals 10.5 minus 2 from both sides, and I get 8.5. Why is that smaller? Well, if 6 is bigger than 5, then this one should be bigger than that one.
Maybe that one's just flipped over. You ever think about that? Like the 8.75 should be the bottom.
Yeah. Oh.
No. Confuse the teacher. Teacher doesn't know what he's doing.
I know what I'm doing.
Maybe it's doing this kid's got an idea.
Well,
No, he must subtract.
it is.
No, but you had to subtract.
Yeah, but you're assuming that x and y are the same number by saying that.
Down there in the thing, it's y plus 2. To get y of but we solved for y. Yes. You gotta know what y is. Like on the other one we solved for x. X was there. Y, we got y. Because this plus 2. This x right here is very. The line is labeled y plus 2. If you took out y and put y, you took away the plus 2 as well. So that's really 8.75. It should be 10.
What do you mean I took the y plus 2 off?
I think maybe we should just. It's y plus 2. You figure y. Took the 2 out of y to figure y.
No, I did y plus 2 right there.
Down there, bottom.
Down at the bottom?
Y plus 2 equals 6. Got it. It is. So we figured y equals 8.5. But 8.
Oh, yeah, yeah. Oh, the side is, oh, God. Thank you, guys. I'm a little slow some days. Today is one of those days.
Math class.
Y is 8.5, but the side is 10.5. That's what you're saying. That, yeah. Don't show anybody this. I'm not posting this one. Some days even math teachers have brain cramps. I thought you guys were saying Y was that, but Y wasn't that.
Y is plus 2.
Yeah. All right. Definitely gonna have to delete that one. No. I'm gonna see how many views it has next time. All right. Hey, you guys get this? Okay. I think we're ready. Hey, how many of you guys know what a scale drawing is? How many of you ever seen blueprints before? What are blueprints? They're scale drawings of what? Yeah. So how many of you guys have ever helped frame a house or build a house or something like that and you had to read blueprints? Okay, if you've ever looked at blueprints right there, usually you know something like 1/4 of an inch represents a real foot. And so when they build the house, they have these big old these blueprints right here, and each 1/4 inch on there represents a foot. And so you can see what the scale is, so you can get everything right. And so blueprints is an example of this. The 10 times projects are an example of this. Model airplanes or model cars versus a real thing is an example of a scaled down version. Okay? Here is your assignment. I don't know if I want to hear this. I don't know if I want to hear this. What is it?
What is the
What's the name? Blueprints.
Why can't they be green prints?
They'd be green prints.
Purple prints.
Yeah.